Assalamu alaikum. Due to the current COVID-19 pandemic, all the JEE aspirants are stuck in their homes. I have started this online lecture series to help all those students. I hope that they will find it very useful. Stay home, stay safe. Assalamu alaikum. Students, last time we discussed the basic circuit theory, and there we discussed the distribution of the currents in different branches of a circuit. We also discussed a few basic problems in the series and the parallel combination of the resistances. Now we will try solving some questions starting with the basics, and then move on to some you can say level 2, level 3 questions. So let's start with doing some problems on this distribution of the current. We can have a simple question where we have to find the, you can say, the current. For example, this is 2 ohm, this is 3 ohm, and this is 5 ohm, and we have a battery. It is 10 volt battery. So I'm not writing the ohm, I'm not writing the sign. Let's save the space right now. So we have this circuit and we have to find the, you can see the currents. Simply the total current, we can find it. It's very easy. It has already been covered. So 3 plus 2, it is 5 ohm. This much of resistance. These two are in series. So 5 and 5 are parallel. That means 2.5 is the net resistance of the circuit. And the potential difference that we are applying across these resistances is 10 volt. So obviously the net current flowing through this battery that's providing the energy, that will be 10 divided by the net resistance, that is 2.5. So net current is 4 ampere. But this is not the question. It means 4 ampere current we are getting through this limb. Now this current will get distributed in these two limbs. Now as we have already discussed, the distribution of the current into parallel these limbs. So these two limbs are parallel, but we have to make sure that 2 is not in parallel with 5. So 2 ohm and 5 ohm, they are neither in series nor in parallel. 3 and 5, again the same case, neither in series nor in parallel. But 2 and 3, since the same current will flow through both of these resistances, so they are in series. But the combination of these two, since the potential difference applied across this 5 ohm resistance is the same that we are applying across the combination of these two, so the combination of these two is in parallel with this one. So the combination will be 3 plus 2 is 5 and 5 parallel. So these two limbs, we have 5 net and here 5 net. So the current will get distributed in the ratio 1 by 5 is to 1 by 5, and that is equal to 1 is to 1. 1 is to 1 means 2 equal parts. So 4 ampere current will come from this you can say limb and get distributed into 2 equal parts. And what are the 2 equal parts of a 4 ampere? If we break it into 2 equal parts, so it means 2 ampere current through this and 2 ampere through this. Very simple question. Now let's analyze some other parameters for you can say that will also help us to analyze the circuit. So we can start with the 0 volt. Why? So we know the behavior of the potential in the circuit. At any point we can say assign that point with some potential value. So this is kind of a frame of reference for this circuit. Now we cannot, can say, assign two nodes some value at the same time. So any node we can assign some potential value. With respect to this value, we can, you can say, calculate the potentials at other you can say different nodes within the circuit. So this is all right for us. We can assign it the value of 0 volt, 5 volt, 10 volt, x volt, whatever you want, but 0, this always helps. So if this is 0, simply this is 0. If this is 0, there is a rise of 10 volt from negative to positive, it is simply rise. So we can say this like this. So positive and negative. It doesn't mean that this is positive and this is something negative. Rather, it means this plate, this is at the higher potential and the lower potential, and current always flows from higher to lower outside the battery. So, and battery, again, we have to make sure that we understand the concepts very clearly. No need to tame any or just to grab any misconcept. I would highly recommend a book, Concepts and Misconcepts in Physics by Ram Tulli. Very good book. So battery is not providing the charge. Battery is only providing the energy. Charge is already available within the conductor. Even the resistor, it is conducting the charge. So the charge is already there in the circuit. What battery is doing is only providing the energy to that charge. So here, if we are assigning the 0 volt potential, any electron coming from this area will have an energy equivalent to, you can say, 0, as far as the 0 volt is concerned. Rest of the energy analysis that we will discuss in the, you can say, more advanced classes. But right now we will discuss the potential, you can say, potential at different points in the circuit. So this is 0, this is 10. If this is 10, again 10 volt. Now this is 10, 2 ampere current is flowing through this 2 ohm resistor. Again, in the direction of the current, there will be drop. Drop, we can say right like this. How much drop will be there? So IR 2 multiplied by 2, that's 4 volt. So 4 volt of drop means decrease. So here the potential was 10 volt. There is a decrease of 4 volt. The remaining 6 volt. So this point will be at a potential of 6 volt. 6 volt when we set this point at 0 volt. We will also change this reference. For the sake of argument, we can change this. We will do it later on. Now again, 6 volt, there is again the current 2 ampere is flowing through 3 ohm resistor. The drop there will be 3 into 2 is 6 volt. So 6 volt drop. So the potential at this is 6 volt, and there is a decrease in the potential. The drop in the potential is 6 volt. So 6 minus 6 remaining 0, and 0 it's already there. So whatever we did, you can see this is a kind of verifying this, whether we are doing it in the right way or not. But we don't do it in our, you can say, exams, especially in JEE. We never, you can say, verify our answers like this, because it's time consuming. Even if it, you can say, it takes us 30 seconds or 20 seconds to verify this answer, that's again a wastage of time. So we have to employ our time in a very, you can say, proper way there. Again, from this side, 10 volt, 2 ampere current is flowing through 5 ohm. So the drop will be 5 into 2, that is 10 volt. Drop, decrease. So the potential at this point is 10 volt. Then there is a decrease in 10 volt. So the remaining 10 minus 10 is 0. Again, this is 0. Again, verifying the same. Now, few, you can say, students, they might, you can say, try this one. What if we change the value of this point, the potential of this point, we don't start with 0, we start with 10 volt. Actually, potential, we know potential at a point, it depends on the frame of reference, but the potential difference doesn't depend on the frame of reference. And generally, when we define the potential that we have done in our, you can say, earlier, you can say, sessions, we have done the field theory, we have done the conservative and non-conservative forces, and how the things work, how the potential energy we calculate there, and how it works. So if we change it and we write instead of 0, we start with 10 volt. This point is 10 volt. Can we do it? Yes, we can do it. Okay, can we write x volts? I will just assign a value here, x volts. Yes, I can do it. It's not a problem. So I can assign this point any value, but we have to make sure, and this is a serious issue if we don't understand this thing. Any point within a circuit, if we are assigning some, you can say, arbitrary value, it means we are a kind of creating a frame for that question. And we can do this only, you can say, for a single point. We cannot assign this arbitrary value at different nodes within the circuit. Why? Because assigning a value to any node within the circuit, it creates a kind of a frame of reference. So with respect to X, we will be determining the value of potential and potential differences within the circuit. We cannot assign 2 or 3 points with the same value. That's totally absurd. So let's suppose we are assigning 10 volts. If this is 10, this will again be 10. If this is 10, so this will be addition of 10, that this will be 20. If this is 20, this will again be 20. Again, now 20, now this is 10. The potential difference is again 10. So all the answers, potential differences within the resistances, then the potential at the points. So see, we have to understand this thing. The potential at different points will change. In the earlier case, it was 0, 0 and 10. Right now it is 10, 10 and this is 20. So individual potentials change, but the potential differences across different resistors, that potential difference, that doesn't change. We have to see it. The potential difference will always be the same. The potential difference across the resistor is 10. It was, before this it was again 10. If we start with X, the potential of this point will be X and the potential of this point will be X plus 10. Now the same X plus 10, we can write it here. The potential at this point is X plus 10 and this is X. Now what is the difference? The potential difference between these 2 points? X plus 10 minus X, again 10 volts. So potential difference will not change. Now why we have to discuss this thing? In JEE, at times what happens, within a question that we already have, we have a kind of a preconceived idea about this potential, and we assume that this circuit we will start with a 0 potential point, but they start with something else. And it is always a case that they start with a kind of a variable, maybe X, and then we start thinking that why they are starting this with X. So because they are, you can say, they want to know whether we know this or not. So they are just checking our this conceptual power in those you can say moments. So this is a very simple question, but we understood a couple of, you can say, things, a couple of concepts. One, the potential within the circuit, potential at different points, the drops, the distribution of the current, and how it, can say, works. We will switch over, you can say, now we will start with, you can say, a better example. So let's say we have an example like this. So this is 2 ohm. I'm not writing the ohm. So I think we are done. Let's change this and write here 18. Fine. It's all right. And this we will write like 80 volt. So the battery is like this, connected with the circuit, and we are asked to find the current flowing through 6 ampere. Fine. So one way is that we will start with the current law or the loop law, and we will start with the loops and the stuff. So that is the proper way, but again there is a limitation with that, you can say, method. The limitation is it is time consuming. So how we will employ it? Very simple. Let's start with the reference. and we have discussed that reference. We start, you can say any point we can give any reference. For example, this is a 0 volt, 0. If this is 0, this will be 80. There is a rise in 80 volt. So if this is 80, this is again 80, and this is 0. Fine. One way of doing this is we can assign this value some x. That we have already done. 5 types of circuits that are asked in JEE. Only 5 types of circuits are asked, and we have already completed it. But this is not about those circuits. It is about distribution of the current. So we can simply calculate the net resistance. That is one of the simple, you can say, ways. 2 plus 2 is 4. 4 and 4 parallel. It is 2 ohm net resistance. In series with 6 plus 3 is 9. 18 and 9 in parallel. So 18 by 3 means 6. So this is 6 and this is 2. 6 plus 2 is 8 ohm net resistance. And the current, net current will be 80 by 8, that's 10 ampere. So I net equal to 10 ampere. We have to do it like this. At board level, we can, you can say, go for those long equations and start doing it very, you can say, step by step, writing everything there. So it's more like writing a story that once upon a time there was a resistor, 2 ampere current used to flow through this. Next step, what I did, I just took out, you can say, took my pen, then started writing, and the story goes on. But to be very frank, in good, you can say, exams like JEE or NEET or JIPMER or you can say AIMS, the time is very precious. We cannot, you can say, start writing all those stories. So this is the way how we do it. Very simple. We have to do it very, you can say, fastly, and we have to anticipate, you can say, the answers. We have to anticipate the methods we are going to use, why we are going to use it, why this question has been, you can say, devised at the first place. Anyway, the 10 ampere current flows like this. So 10 ampere goes like this. Then there starts the distribution. Now we won't be calculating the, you can say, individual currents. First the total current, then after that, you can say, doing the analysis of every loop. No, let's start with this. 10 ampere current is coming through this limb. It gets distributed into 2 limbs. So this is 6 plus 3 is 9 ohm, 1, and 9 ohm is parallel with 18. What will be the distribution here? It will the distribution will simply be this is to this. I1 is to I2. So I1 is to I2 will be equal to 1 by 18 is to 1 by 9. Multiplying both sides by 18 because that is the LCM. So this will come up like 1 is to 2. So we have to make 3 parts of this current. 1 part will flow through this and 2 parts through this. And this is again logical. This is higher resistance, so low current will flow through this. This resistance is half of this. So it means double current will flow through this, you can say, path. 1 is to 2. So the value of current through this I1. So I1 will be equal to 10 multiplied by 1 divided by sum of this, that is 3. So 10 by 3 amperes. And I2 will be double of this, simply 20 by 3 amperes. And we are done. Again, this current will, you can say, combine over here. And we will get 10 amperes. Now this 10 ampere will again get distributed into 2 paths that are, you can say, again they are parallel. The combination of 2 and 2 is parallel with 4. Now this single 2 is not parallel with 4, that we know. So 2 plus 2 is 4. So this is 4 ohm. This is again 4 ohm. Same 2 paths with equal resistances. The current will get distributed in the ratio 1 by 4 is to 1 by 4, that's 1 is to 1. So 10 ampere, so like this 5 ampere and 5 ampere. So we are done with this question. Now again, the question, this is very simple, but we have to practice more questions like this. Let's start with a, you can say, more of a kind of a good question, a good one like this. For example, if we have 10 volt battery, then we have like a resistor like this. We can have a resistor like, for example, this is 6, this is 8, this is 8, this is 8, rather this is 6 and this is 2. Let's solve this. So everything is given there. We are asked, actually this was asked in one of the, you can see, JEE papers. I think in 2013 or 14 it was asked. The value of current through this is, no, nothing is given. They want to find this, the current value over here. The moment you just look at this question, it looks very simple. Yes, it's easy, but the problem with this question is it will, you can say, consume our time. We have to save our time. Otherwise 90% of the students, most of the students rather, they will easily, you can say, get the answer of this question. They can easily solve this. Now how to do this? Very simple. We don't need to find current in anywhere else, but we need to find the net current first. That's important. So simply what to do? We will try to find the net resistance. So the resistance is 6 plus 2 is 8. 8 parallel with 8 is 4. 4 plus 8 is 12. 12 parallel with 6. 12 parallel with 6, that is 4. How to do this? Actually, if we have any resistor R and there is a parallel with R by 2 resistor and it's half, they are in parallel, that the net resistance is always R by 3. This we have to remember. We can remember, or we can do it. Simple, multiply and divide. You will get the answer. It's very simple. So 12 parallel with 6, since 6 is the, you can say, half of 12. So the answer will be 12 by 3. That's 4. 4 plus 5. That's 9. To make things very simple, I will change the value of this battery to 9 volt. 9 or 18 or some multiple of this. So 9 ohm resistance and 9 volt battery. So current value is 1 ampere. So 1 ampere will flow through this. Then 1 ampere will come through this. And now it has two paths. One path and second path. And what is the ratio of these resistances? Or rather, what is the value of these resistances? This one is 6. One path, 6 ohm resistance. The second path is combination of all these, because this is the single path. So combination of these two is 4 and 8 plus 4 is 12. So this part is 12 and this part is 6. So this 1 ampere current gets distributed in these two, you can say, parts of the circuit. So how we will do it? Very simple. Again, I1 is to I2. Let's call this I1 and this I2. I1 is to I2 will be equal to 1 by 6 is to 1 by 12. And again multiplying by 12. So it is 2 is to 1. This is double. Half the current will flow through this. So 2 is to 1. Now again, we don't need to find the current through 6 ohm. We don't need that. We only need to find this current. So what will be current through this? What will be the value of this I2? So it will be this. If we can say break this current into 3 parts. So 1/3 of this current is 1 by 3. Multiply by 1. So 1 by 3 ampere. Through this. Now again this current will, you can say, get divided into these two parts. Now 6 plus 2 is 8. 6 plus 2 is 8. So it means half of current. So 1 by 3 ampere will get divided into 2. So divided by 2. So it is 1 by 6 ampere. Again 1 by 6 ampere. So answer is 1 by 6 ampere.